Good afternoon, everyone. Thanks for joining us this afternoon. Thanks for having us here. Excited. So my name is Chris Weber. I'm a product manager on the Meraki MX product team.
And I'm Chris Pacheco. I am a TME on the MX product team.
So we'll keep the names easy today. Our agenda for today is pretty straightforward. We're going to talk about three different topics and introduce kind of three new concepts when we start talking about next-gen firewall and the MX platform. The first is this idea of cloud-delivered firmware-independent upgrades. We know that managing firewalls is complicated. Meraki makes firmware management pretty easy, but we took it a step further. We will talk about how we're accelerating performance in the platform and introducing a new concept that we're referring to as the quote-unquote software ASIC. And we're going to introduce another concept called the SOC, which is this unification of the NOC and the SOC. And that's really driven by the XDR integration that we announced earlier today. So to kick it off, I'll hand it over to my partner in crime here, Chris, and to talk about the lifecycle updates.
All right. So our first topic here is simplifying the firewall lifecycle. Now, when I say that, I'm talking about, let's say we need to upgrade the firmware for an MX, a firewall, something at the edge, right? And it could be upgraded for many reasons. Maybe there's a new CVE, maybe there's a bug, maybe there's just a new feature that you want to use. And, upgrading means downtime. And from the Meraki side, we've tried to make this easier, right? You can upgrade firmware at the push of a button. But we try to take that a step further. And with this slide, you'll see that we have the data plane for the MX, right? Now we have all our features here. So we have routing, VPN, layer 3 firewall, etc. Now, if you look on the right-hand side, you'll see a green box. And that's the Meraki application platform. And just above that, you'll see there's two items that are outside of that data plane. And that's Snort as well as Thousand Eyes. And the reason that they're out there is because we can update these two containers from the cloud without any need to update firmware. It's just automatically pushed directly from our cloud to the device at the edge. And this really helps us leverage things like CI/CD practices. It allows us to update quickly and efficiently. Now, if we look here, you'll see that we are using Snort on Meraki. We're using Snort for IPS on most of our products, right? Now that means it's the same Snort that you get on Secure Firewall. It's the same Snort on SSE and same Snort on Meraki. Now we work with the same Snort team, and if you look at this, we have the Meraki cloud and we have the SSE as an example. Now, just under those clouds, you'll see that we have some nodes. So we have 3 MXs just under the Meraki cloud, and we have 3 POPs under the Cisco SSE. And you'll notice that they're running versions of Snort of 3.173. Now, let's say the Snort team, they develop a patch, they develop something new for Snort. Now, let's say we have to upgrade to 3.174 as an example. So this is the brand new version. They can distribute that to our clouds. And each cloud will consume that update. They'll test it against their respective products. So in our case, we'll test it against the MX, and the Cisco SSE will test it for their POPs. Now, once testing has been completed, all the QA is done, we push that update out to our MXs. And the same can be done from the Cisco SSE, so to their POPs. And after they're all upgraded, this is done without any firmware updates at all. It's just strictly, like I said, pushed from the cloud, tested in the cloud, and then updated at the node. Now, over the last 14 months, we've had roughly just over 5 updates to the Snort container. This is whether it's updates for bugs or just enhancements in performance. And that's truly like the power of the cloud, right? We can upgrade over 700,000 nodes across the world in just a period of 24 hours. And now I'll hand it back over to Chris to talk about performance.
Thanks, Chris. So cloud agility, that's awesome. Everything you talked about in terms of enabling faster upgrades, us to respond to threats faster, that's excellent. We know the other area we need to accelerate is performance. Bandwidth is not going down. 5G is accelerating everything on that front. And so we're continuing to evolve the platform to look at how we get more performance per core out of any given platform, because that's just where we're going. And we've been hard at work on a really powerful integration here and a whole new architecture that we're introducing into the MX portfolio, which is really a combination and bringing together of the Meraki technology that we've been developing for the past decade, as well as the Cisco VPP technology that we've been developing within Cisco for the better part of a decade. For those that are not familiar with VPP, vector packet processing, it is the world's fastest software data plane technology that Cisco has built and open sourced to the world. And we've been working on putting that into the MX portfolio as a really fast path in our data plane to accelerate performance. And so this is where we're starting to introduce this concept of a software ASIC. And I realize that is an oxymoron saying that, but I'll walk through a bit of what the architecture looks like and really why we look at this as a, as a quote unquote software ASIC, because the outcome is really very similar in nature. And so a little bit on VPP. So VPP is, as I said, the world's fastest software data plane. There is nothing in terms of software data planes that can forward packets faster than VPP. On Intel servers, you were talking about terabit per second, crypto performance, all in software, no hardware offload, things like that. In our platforms, we're looking at multi-gigabit per second per core on VPN and IPS, and I'll get into that a little bit more in a minute in the demo. But it is something that we open sourced to the world because we wanted to continue to foster data plane development. And so now we have industry leaders like Intel, ARM, and Marvell that are co-developing VPP with us to accelerate their own individual SOCs as well. It does power some of the world's largest data centers like Alibaba Cloud, Equinix, for example, a couple of customers who adopted. But it also runs across a growing number of products within Cisco. Some might not be aware of it, but the WebEx platform, for example, actually runs on VPP to handle the high volume of voice packets and data that's coming to the platform. We also run it across our SSE and SASE platforms, Secure Connect and Secure Access, to accelerate performance in the cloud. And so we're continuing to bring that same technology all the way down to the edge in the MX firewalls as well. So I want to deep dive for a minute into what the architecture looks like and why I reference this in an ASIC fashion. So we have the very similar diagram what Chris showed earlier. We have all these blocks of features and components in the service channel on the top. Things like the firewall, things like routing, QoS, packet inspection, all those things, and the Meraki application platform that he talked about. But underneath that, we're introducing another layer, which is this fast path, quote unquote, ASIC layer, powered by VPP. So we continue to maintain the higher order, call it slow path that we've always had. That's where all the decision-making logic happens in a flow. So how do I need to route this? Do I need to encapsulate this in a tunnel? Do I need to block this with a firewall rule or security policy? But then underneath that, once we make a decision, we can forward that packet, the rest of that flow, very quickly. We've also introduced, in terms of the containers over here on the Meraki application platform, a zero copy interface as well to that fast path. Because we know that features like IPS, for example, are the most bandwidth or the most performance impacting capability in any product. And so we need to continue to make that faster. It doesn't matter if you make everything else really fast if the core security thing, when everybody wants security these days, is really slow. And so we've also made that a zero copy interface so that we can get some really amazing performance out of that. So let's talk about what a life of a flow actually looks like in this model. So when we're talking about the first packet here of any flow, the first packet's going to go come in through hardware, go up through the VPP layer, and then up to that slow path where we're going to start passing it through every component, every feature in that service chain. And that first packet's going to go through the routing, the QoS, decision making, the IPS protection, the firewall policy, all those things. And we're going to determine what we need to do with the feature, with the packet at every single one of those hops. But once we make that decision of how do we need to route the rest of this flow, we program that decision into VPP so that the rest of the flow from there can pass through the VPP layer. It doesn't have to go through that slow path through all the features, and we can get it out of the platform, get it through the tunnels or DIA or wherever it needs to go very, very quickly. And things like, if you're using the IPS features for the threat protection, that will continue to send every packet through the IPS layer. But that's why we brought in that zero copy interface layer, so we can continue to send the entire flow through that IPS layer, but still maintain a high degree of performance with that. We are introducing 2 new products to start that will leverage this new version of our operating system. That is the VMX XL on AWS, which we GA'd last week. The VMX portfolio today, the small, medium, large platforms, scale up to a 1 gigabit per second performance, VPN performance on the VMX large and 1,000 tunnels. With the VMX X large in this architecture, we were able to 10x that in the first iteration. So 10 gigabit per second of IPsec performance and 10,000 tunnels on a single 8-core instance. So super efficient, low number of cores. We don't need a high number of cores to achieve this performance. We can continue to scale really well all in software, and there's no hardware offload in this. And then we are introducing the MX 650 this week as well, which is the next gen in the high end of the MX portfolio. The highest end of our MX platform today, the 450, is a 10 gigabit per second appliance. And so we've over doubled the performance on the VPN performance on this platform, the NAT performance, and we're getting significant performance improvements on the threat protection throughput as well, all thanks to this architecture design. So we will be launching that later this calendar year with the VPN concentrator as a use case to focus on first, because that's where, frankly, 50% of our customers deploy. That's how they deploy these high-end appliances today. So it's really geared at that high-performance aggregation use case. I want to do a quick demo before I hand it back to Chris. So I've got a very simple topology here. I've got an MX 650, and I've got 4 VPN tunnels, one going to each of these 4 VMX XL platforms here. On the left-hand side, I've got an Ixia breaking point client. On the right-hand side, I've got an Ixia breaking point server. So I just want to run through the demo really quick and just show the performance that I'm talking about here. That it's not just, it's not just a slideware, but it is real performance that we are achieving thanks to this new architecture, this new approach. So I do have Ixia here. You can see the configuration of it. It's configured for about 25 gigabit per second of throughput. About 12,000 flows per second that it's going to start generating. And here in dashboard, we have the MX 650, the new product line here online. And you can see under the menu, I've got 4 VMX XLs that are deployed there as well. I've got Meraki's Auto VPN turned on between each of them. You can see they're connected, they're online. I'm just going through a little bit of the configuration here. We'll jump back to the 650. And once it's online, we're going to head back to Ixia. We're going to start it up. So for those that have seen the breaking point platforms, these traffic generators before, it takes a bit of time to ramp that up. So I'm going to start it, and I'm just going to skip to the more fun part here. So you'll see it start in a second, start generating a few megabit per second of traffic on the right-hand side there. I'll skip ahead here in a second, and you'll see it hitting the 25 gigabit per second of throughput that we're talking about. So we're at about 24 gigabit per second there across 4 tunnels. And this, just to put into context, that's all encrypted traffic, so it's going through the IPsec tunnels, those 4 tunnels, and the uplink on that platform is a 25 gig link, so we're pushing the line rate on that. We don't have another link in this particular setup, so we're basically maxing out the line rate on this box.
Fixed packet size, or have you got variable packets going?
It's EMX traffic, so there's variable packet sizes and different application protocols. Yeah. So that's all I want to show. You can see in dashboard there, we're pushing about the 24 gigabit per second represented there. You'll see the 2 lines because one is just one is the upload direction and one is the total, so upload and download. So you got all the traffic coming in and then egressing through a tunnel. So amazing performance that we're achieving out of that ASIC, that architecture. We're going to continue to take that across the MX portfolio going forward. You'll see a lot more of that coming. But with that, I will hand it back to Chris to talk about the SNOC.
All right. So for the SNOC, basically, we want to put our security hats back on. We saw some really cool innovations with VPP, and now, we're still using Snort. We are bringing security all into one place. And when I say that, we have the network operations center, we have the security operations center, and when we say SNOC, we're just combining those two, right? It's the overlap between the 2 teams. They do work very closely because, if there is a security event, you want to check out flows. Maybe you have to talk to the networking team. But what we're doing in dashboard is we're trying to bring all these things together, right? We have Thousand Eyes. We're bringing that into the dashboard already. We have Umbrella that's already been integrated with the dashboard, and now we have XDR. We're bringing XDR into the dashboard as well, and we're actually taking that a step further, right? For those online that aren't aware of what XDR is, basically what it does is it takes in telemetry, right? So it could be maybe API-based telemetry. It could be more commonly NetFlow telemetry. And it takes that, it runs it through some AI, ML, some more advanced analytics, and it tries to make detections, right? It's trying to detect, is there something malicious going on? Are we getting away from our baseline of networking? Is there any indicators of compromise? Like, what are we talking to? And is there a potential incident? And once it crunches all this data and it determines, hey, yes, there is something going on, that's when XDR will actually create an incident. Now, for For our integration, what we're doing is in the Meraki dashboard, you will be able to go through an all-off flow. You'll sign into your XDR account, and we'll be able to pull incidents into the Meraki dashboard. So XDR incidents in the Meraki dashboard, you can view them and you can manage them. But I think the cooler part is we can actually export flows directly from the MX and send it out to XDR. So that means you don't need any sensors like you previously needed for other types of deployments. You don't need a flow collector or anything like that. That's it. The MX is taking all those flows that are flowing from LAN to WAN, LAN to VPN, it doesn't matter. We're exporting all those flows from the MX to the Meraki cloud, and then we're sending over to XDR. And to really give you a deep dive under the hood of what this packet flow looks like, if you look across the top, this is your traditional path, right? So on the left-hand side, you get the packet in, it goes through the MX, so it's received by the MX, it goes through a component called traffic analytics, and then after that, it'll go through other features. So say if you have AMP turned on, if you have content filtering turned on, any of those features, right? And then it gets transmitted out to its destination. In this case, let's say, I don't know, we're on the LAN, we're going to a website. Now, when that packet passes through that second part, the traffic analysis piece, we'll collect that flow in the kernel, and then we'll copy it over to user space. In user space, we have an application. We have an application that's handling both TLS as well as the collection of those flows, and it's encrypting it. And about every 60 seconds, it'll send it out to our cloud, and then we send it over to XDR. Now, I say every 60 seconds only because if the oldest flow is 60 seconds old, bam, we'll send it out. But it could happen sooner, right? Say maybe you have a lot of flows going through this. You can't send them all in one packet out to XDR, right? There is an MTU. So if either the buffer's full or we hit that 60-second mark, we'll send this traffic out. And it is from the MX, it's a separate TLS connection going to the Meraki cloud. It's not using the same management connection. And if we look at this from the cloud side, so on the left, we have the Meraki organization. Let's say we have a couple of networks all connecting to the Meraki cloud, right? And on the right-hand side, we have XDR. So all the networks will send its data to the Meraki cloud. Meraki cloud copies that over, sends it over to XDR's data lake. And then from there, XDR kind of does its thing. It's doing the analysis on the flows and determining whether there's actually an incident or not. Now, I also mentioned that we'll show the incidents in a Meraki dashboard, and we're doing that all via API. So we're not storing any XDR information in the Meraki dashboard. So any of the incidents that you actually see there, it's all being pulled via API. So that allows us to do a couple of things. We can update the incidents and have that reflect in XDR, right? So if you make a change in Meraki dashboard, those changes will be reflected in the XDR incidents page.
Is the XDR analysis an additional licensed feature, or was that just included with the product as is?
Yeah, so you will need an XDR license, right? So you'll have to have XDR already. But if you have advanced security, then advanced security or SD-WAN plus on the MX, you'll be able to use this feature.
And is this just visibility in the Meraki dashboard, or are there opportunities for action to be taken based on those events?
Yeah, so that's the next piece. First we need to get the data into the Meraki dashboard. We have to get data out to XDR. The next piece that we would like to work on is actually responding to those incidents, because that's what really matters, right? You want to take action on those incidents, or maybe maybe it's just like, oh, hey, this is okay. Maybe it's expected. Maybe you're testing. But yeah, definitely a great question. And this is just a quick demo. So this is the Meraki dashboard. Right now we're looking at the organization summary page. We will have a new incidents page. There you'll be able to connect to your XDR account. So it'll go through the all well flow. You'll get redirected back to the dashboard. Now, the first thing we do in this scenario is we're configuring our networks, right? So we want to know, we want to send these MXs, or enable these MXs to send data to XDR. And we just do that just at a click of a button. Again, no need to deploy any sort of sensor, no spinning up a new VM or sending somebody on site to install a new device. And then in Security Center, we'll have all of the XDR incidents. And again, this is, every single incident that you have in XDR is showing up here. There's a couple of different ways to filter on it. And then if you click on the incident, we're also pulling in additional data, right? It's from XDR. So we get the same exact look and feel as if you were in the XDR platform. And then at the click of a button, if that's not enough, we can go back over to XDR. And it'll actually bring you directly to that incident itself. All right. That's it for the demo. I guess any questions on this? Any other questions?
The visibility that you have, so like if there's a ransomware event or like data exfiltration or something that you're seeing, are there active links within that event in the Meraki dashboard that links you to the client or the switch or?
Yeah. So everything that you see in that side drawer, everything that would pop up regarding any observations or clients associated, it will, if you click, bring you to that client in XDR.
Wait, does it bring you to the client in the XDR or the Meraki dashboard?
In XDR.
Okay.
Yeah.
But we will be linking that to the client in the Meraki dashboard as well. So both the network, linking to the network and the client, because this sits at an organizational level, right? So there's a few things I want to know from there. Well, which network generated the incident and then which client. And so if you think about the previous model of how this stuff worked with StealthWatch Cloud, for example, or any other kind of flow-based detection system, usually you have to deploy a NetFlow collector on-prem, export your NetFlow to that thing, and it's going to proxy it up to the cloud or wherever it does its analytics. Part of what we've done here is when we send that data up to the cloud is we enrich that with the network ID, the MX serial number, the organization ID, and all that is additional context that gets surfaced in an incident. So even if I'm a security analyst and I'm operating inside the XDR platform, I know that this is something that was generated from my Meraki environment, and I know right away which serial number, which network, and then even which client, that when we link down to the client level that generated that incident. So really bring it all back together.
Yeah, and it's actually all the identifiers that we're using for the network are in the future when we do need responses, we can make API calls specifically for that network to make those changes.
From the dashboard as well here, you'll see this assigned and status indicators as well. So you can actually not just view the incidents in the Meraki side, but you can actually assign an incident to whoever's going to be triaging and working on the incident. You can also resolve an incident, change the status, is it closed, is it in progress, whatever it is from there. So I don't have to just do an immediate cross launch. I can get a whole bunch of information in the side drawer that Chris showed, and then I can take some of these actions on the incidents, you close them out, and even just manage them from the Meraki side. So just continue to bring the network and the security closer together.
All right. So for this next piece, it's just really showing the future, right? We have the pipeline for that data. Now, what other integrations can we bring in? We're already connecting with XDR, but what if we send some of this data to Talos? Like that would be amazing. Thousand Eyes, there's a potential for a lot of different integrations to get your specific data into those platforms if that's what you wanted. So Thousand Eyes is probably a great example.
The really big thing here is XDR is the first consumer of this data, but the really big part is getting that data at cloud scale off of the devices into any analytics engine like this. To put in perspective, there's over 2.1 million MXs deployed globally today, and across those, there's over 16 trillion flows of traffic a week. So being able to get NetFlow or like logging visibility of all of that stuff at that scale, that's been really the focus of what we build here, is something that can ingest 16 trillion flows of NetFlow data per week and hand it then into any analytics engine. Be it Splunk, XDR, Thousand Eyes, anybody that needs to consume this data for their analytics.